Good morning, everyone. Today's lesson is about evaluating logarithmic expressions. I have a lot of examples here for you, so let's go straight to the first example. Here, we need to find the value of logarithm 49 base 7, and what I usually do here is I create an equation from this that equals x, or question mark, and the next thing that I will do is to transform this or convert this into exponential equation. This will be equal to 7 raised to x equals 49. So that's 7, this one, raised to x, which is the exponent, equals 49. And of course, we understand that we can express 49 as a base of 7. That's 7 squared, right? Can disregard that 7, therefore x equals positive 2. All right, let's go to the next example. Okay, again, I will convert this into exponential equation. Into an equation rather, and then convert into exponential equation. This will be 6 raised to x equals 1. And of course, you might be thinking, how will I express 1 as a base of 6? Well, if you understand or familiar with the laws of exponent, any number raised to 0 equals 1. So that means we can express 1 as 6 raised to 0. All right? And disregard the x, and that will give us x equals 0. All right? Let's go to the next one. This time we have a fraction. Again, I will write it like this first. Logarithm 1 over 81 equals x, which means 3 raised to x equals 1 over 81. And then you need to express 81 as a base of 3 because we have a 3. We have the base 3 on the left side of this equation. So that means this equation is the same as 1 over 3 raised to 4. 3 times 3 times 3 times 3 equals 81. Now, using again one of the laws of exponent, we can express 1 over 3 raised to 4 as 3 raised to negative 4. Right? So therefore, our x equals negative 4. All right, let's go to the next example. Okay, so here we have logarithm 1 over 100 equals x. And of course, some of you may be wondering what is our base here. So by default, if you don't see a base, that means that the base is 10. All right, so this is 10 raised to x equals 1 over 100. And just like what we did in the previous example, we need to express the denominator as a base of 10. So 10 squared, which means using the laws of exponent, that will just be equal to 10 raised to negative 2. And we can disregard the 10, therefore x equals negative 2. Okay, let's go to the next one. All right, so here we have logarithm of the 4th root of 512 based of 8 equals x. So I want to express this into exponential equation to solve for the value of our given here. So this is 8 raised to x equals 512. I will express that radical sign, or radical number rather, into exponential form. So 4th root of 512 is the same as 512 raised to 1 over 4. And of course, the next thing that we will do here is to find the base, or to express 512 as a base of 8. All right, and that equals what? That is right. 512 is the same as 8 raised to 3. All right, and what are we going to do with that 1/4? Well, we will multiply that 1/4 to the exponent of 8 raised to 3. So now we have the same base. That means our x is 3 over 4. All right, let's go to the next one. Okay, so we have an ln here, ln. So logarithm, natural logarithm rather. If we have a natural logarithm like this one, we can express that as, okay, let me just write the problem first. ln the fourth root of e equals x. So this is the same as, yeah, I can do that. Logarithm based e, and then we have the fourth root of e equals x. And I will convert this into exponential form or exponential equation. This will be the fourth root of e equals e, or e raised to x equals the fourth root of e. And of course, the fourth root of e, we can express that as e raised to 1 over 4. So clearly, x equals 1 over 4 here. All right. So let's have another one. Again, here we have a natural logarithm e raised to 3. So this is logarithm e raised to 3 base e, which is equal to x. And e raised to x equals e raised to 3, which means that x equals 3. All right. Okay, let's have this one. So logarithm 9 base 243. Let's see. This will be 243 raised to x equals 9. Now, here we need to again express 243 as a base of 9 if we can do that. So can we express, the question here is, can we express 243 as a base of 9? I don't think so, because 9 squared is already 81 and 9 raised to 3 is 729. But we can express 9 as a base of 3, and we can express 243 as a base of 3. So 9 is equal to 3 square, and 243 is the same as 3 raised to 5. All right, so now we can just disregard the base because they are the same. We have 5x equals 2. Divide both sides by 5, therefore x equals 2 over 5. All right. Okay, let's go to the next one. I think this is the last example. Let's see. Yeah, this is the last example. Again, what I will do is I will put an x there. This will be 64 raised to x equals 1 over 4. And we need to express 64 as a base of 4. You need to ask yourself, can we do that? I think here we can do that. Okay, so this is 4 raised to 3. That's 64, and then of course we have the x. Okay, this 1 over 4, that 4 in the denominator, that's an exponent of 1. So we can express that, the 1 over 4, as 4 raised to negative 1. So that means we can disregard the 4, and we can have 3x equals negative 1. Then just divide 3 on both sides. So x equals negative 1 over 3.